The world has been experiencing a shortage of semiconductors, and this has especially received much of attention during this pandemic. Today in this episode, we're going to talk about the role that Taiwan plays in global semiconductor supply chains. Welcome to the show. I'm Catherine Liu.
I'm Rath Wang. Our guests today are Dr. Tang Mingzhe, the president of Changchun University, a longtime researcher of the rise of Taiwan's prominence in the semiconductor industry, and Marco Mesger, CEO of Numonda, a global expert in the chips industry, having worked across different continents. Joining us later from the US is Alex Capri from the Hinrich Foundation and Conrad Young, former research head of TSMC. President, the US CHIPS Act is warning many investors around the world that it could have a huge impact on the global supply chain. Can you share with us why Taiwan holds such a key and dominating position in the global semiconductor industry?
I think this is because advantages Taiwan have over the semiconductor industry. I think the first advantage is our talents. In Taiwan, we produce over 20,000 electronic engineers every year. And compare this number to the US. The US produce roughly 13,000 electrical engineers every year. And therefore, we have a talent advantage in Taiwan. The ratio of population between the US and Taiwan is 1:15. So we proportionally will produce and concentrate more human resources in electric engineer. And the second is because used to be, we have 90% of the notebook computer industry output around the world. 90%, and therefore, we have already built a very complete ecosystem in Taiwan for semiconductor chips to be used in various products. And therefore, because of the complete ecosystem, that will contribute to the advantage of the Taiwan semiconductor industry. I think the third advantage is lower cost of capital. As you all know, the semiconductor industry is capital-intensive industry. Yes. And the interest rate of Taiwan is one of the lowest in Taiwan, in the world. And therefore, we enjoy three competitive advantages over the world, and therefore, we already have the dominant position in the semiconductor, especially in the foundry industry, not in memory and IC design. But in the foundry industry, we have roughly 60% of the market share of the world.
There are also areas of, in other parts of Asia where they say are more cost-effective than Taiwan, other later players. How would you see that, compete with Taiwan in the market in that sense?
Well, they catch up our advantage.
Yeah, you think about Japan. Japan cannot catch up with Taiwan in the foundry industry. I think another one is the quality of engineers. In Taiwan, you got the master of electrical engineering, and if you receive a call during 2 a.m. in the morning, you will rush to the factory and correct the problem. But it's very, very difficult for the US or other country engineers to do such a thing with that kind of a labor.
Yeah. Marco, we talk about the quality of the talent, we talk about the ecosystem, it's holistic, and also the capital-intensive environment here because of the low interest rate. You've been in this industry for a very long time. Do you have anything to add on regarding our advantage for Taiwan semiconductor industry?
Yeah, sure. I think one other big advantage is also, if you look at Taiwan, I mean, we are a smaller island, right? So this means like you are much closer also for all the facilities, right? This is really, if you look like the US or you look like Europe, like it's a huge country, where basically you have, like in the US, they have now in Boise, in Idaho, they have factories, they do in Texas, in states, it's like huge distances, right? Yeah. Here, I go on the high-speed train, 1 hour, I'm in Hsinchu, I go down to Taichung or Kaohsiung in 2 hours. So I think the communication within this network and group of people, and like mentioned before, TSMC, UMC, all the foundries, they have 60% market share. There's a lot of talent which comes out there, and these talent, if they go out, they maybe also start their own company, design company, go to packaging testing. So you have a very compact ecosystem. Not only an ecosystem, it's also very compact. And that's very unique in the world.
I think it's so rare to have so many factors combined together to to
Right, in this one small place where everyone can come together.
Suppose you work as an IC design company in Taiwan. You design your chip and you go to TSMC. Okay, you may get a sample back 1 week from now. Okay, and then you change and then go back and forth. It's very easy. But suppose now it's a US IC company, IC design company, and then you must go into trouble. You send the sample to Taiwan and maybe 2 weeks, and then you fly here and take it back and redesign. And therefore, because of the close areas, and therefore that we will be able to produce chips in a much more speedy way than other countries.
Speaking of the U.S., all eyes are on the U.S. CHIPS Act. I spoke earlier to Alex Capri, Research Fellow at the Hinrich Foundation and lecturer at the National University of Singapore. Alex spoke about what the act means for Taiwan and the country's role as like-minded countries increasingly band together, resulting in fragmented supply chains. Let's take a look. Alex, with the CHIPS Act, what is Taiwan's role in the further decoupling of U.S. and Chinese supply chains? Could you please touch on the gains and losses for Taiwanese manufacturers? Some have mentioned it could hamper the competitiveness for companies such as TSMC or UMC, where U.S. companies such as Intel would greatly benefit from it.
There's no such thing as a free lunch, right? So with the funds and the subsidies and the tax breaks that come with chips in the United States, which are significant, the U.S. government is going to expect certain concessions from any company, American or otherwise, that takes that money. One of them is it's going to require them to do less business in China, and it's going to really put under the microscope legacy technology. This is older semiconductor technology, much more mature. It could be 1, 2, 3, 4 generations old. It's generally above 10 nanometers when we're talking about the size of the microchip. This has been a staple for companies like Intel and Qualcomm and Broadcom and also TSMC and other Taiwanese companies to be able to sell and to participate in that portion of the market in China because of the huge demand, even for so-called trailing edge, mature semiconductor technologies. Now that we have chips and we have companies like TSMC benefiting from the funds, the U.S. is going to be pressuring semiconductor companies to curtail those activities in China. So the so-called in China for China strategy that's really been a staple now for decades is going to come under increasing constraints.
You've talked about the flight from the rules-based trading order. Will Taiwanese alignment with the U.S. global order around shared values, free capitalist democracies enhance both countries' national security? And how can Taiwanese chip makers balance between market dynamics with national policy?
The question is, can a company like TSMC continue to grow and be profitable and continue to be a major market presence around the world in an environment where we're having, reshoring, ring fencing, so-called friend-shoring of supply chains, right? Where global supply chains are fracturing and they're reconfiguring within geopolitical confines. The answer is yes. I do believe that TSMC will still be able to grow and to benefit, but what it has to do is it's going to have to build capacity in these different ring-fenced markets, just as it's starting to do in the United States. So I would expect TSMC and others to be involved in public-private partnerships with governments around the world, and I would expect to see this is a redundancy, and we can talk about how this affects market dynamics or how it flies in the face of market dynamics. But nonetheless, because of geopolitics, I would see TSMC building a lot more capacity around the world within these fragmented markets.
And with, that breakup, will that benefit, you think, Taiwan and the US in the long run? I mean, having said, having these inefficiencies in the beginning, but in terms of the long run.
It's very hard to say. There in semiconductors, because the barriers to entry are so incredibly high, I don't foresee any of these major changes happening without major funding from governments and major public-private partnerships to get them over the finish line, basically. And that includes challenges with human capital, right? Not having enough engineers to be able to work all of these, these different production, these fabs coming online. How is that going to be dealt with? That's part of these public-private partnerships that have to take place. And so we're looking at a long time horizon here. We're looking at 3, 5, 10 years for some of these new plants to come online. And then the question is going to be, as we look at other exogenous factors like carbon footprints, climate change, clean tech, and so on. These are all industries that are going to demand microchips, and they're also going to demand specialization, right? So there's really going to be a need for these new ecosystems around semiconductor supply chains. So, that's a challenge, but at the same time, that's also an impetus to really invest in these ring-fenced type supply chains. I think the country that's going to have the most difficulty with this, 5-10 years from now, is actually going to be China. If you look at the leading semiconductor nations of the world, the United States, South Korea, of course, Taiwan, Japan, the Netherlands, these are countries that could potentially still have relatively international value chains as they set up these so-called friendshoring environments. Whereas if the direction of U.S.-China relations continues on the trajectory that it is, it's going to be harder and harder for a country like China, which finds itself increasingly isolated, to try and internalize and to become self-sufficient certainly in building leading edge chips. That may never actually happen because it's virtually impossible now because of the hyper specialized nature of global value chains for any one country to go it alone, basically.
Coming back to innovation, not even mentioning, as you mentioned, highly specialized niches where different countries, like-minded democracies partner together. What do you believe is the largest impediment in terms of Chinese innovation? Is it their system? Is it the lack of transparency, or some other issues that come in play?
Yeah, I think it's a combination of things. As Beijing has really committed to throwing a lot of money at trying to build, a self-reliant, self-sufficient semiconductor ecosystem. If you look at the many companies that signed up for them, most of them weren't even semiconductor companies, right? They were in completely different fields, construction, whatever it was. And so, because there was so much money being thrown at this, I think number one, the system, it's a very, very hard to try and push a top-down kind of command and control sort of model, if you will, when it comes to building markets. There has to be a certain amount of a free market of ideas. There has to be a certain amount of risk that is allowed, and of course, that is not the direction that the Chinese Communist Party is heading in when it comes to tech companies, right? It's exerting much more control over them rather than less. So I think there are a lot of challenges, facing Taiwanese companies. And of course, its biggest asset and its biggest advantage for decades has been the inflow of foreign direct investment. It's been technology transfer, it's been foreign direct investment that has played a huge, very significant role in the rise of China. And so if the environment, the business environment, the political environment in China is continued to be viewed as less than favorable, as stifling, or unpredictable, or draconian. So I do think it's China's current system, and also now the history, the legacy that we're dealing with, the geopolitical issues, the South China Sea, the national security law in Hong Kong, this recent series of war game exercises, many other things. We're heading in the wrong direction. It's not very promising, and I would say that that trajectory is only going to continue.
So when we talk about the advantage that Taiwan has, and of course other countries notice this. So recently, the U.S. is injecting over $50 billion to subsidize, to promote U.S. semiconductors, and want to reduce the dependence of other countries into Taiwan specifically. Of course, it has own reasons. Do you think it will actually help to speed up to close the gap?
Well, I think it's not only the US, also the European Union, right? They also have the European Union Chips Act, which is also around about 30 billion. And I think what all these regions try to achieve is that they have some more direct access to the supply chain in their territory, right? So they want to basically have a supply chain where it's not all, let's say, in Asia, but they also have some factories in Europe.
I'm curious, why is it happening now?
Well, I think one of the reasons definitely can tell you is because of the shortages which has happened in the beginning of the pandemic. So Germany, big automotive country, right? So I think the automotive companies in Germany learned the first time that somebody say no to them. When, for example, when in Taiwan, and then that's also what you saw. There have been initiatives. I think the top CEO called from Mercedes, called basically to the CEO from TSMC and basically asked to get something. Now I help you to get this in perspective, and correct me if I'm wrong. I think the automotive portion of TSMC is 1 or 2% of the revenue.
2%.
So I think it's, the leverage is not really there. It doesn't matter if you have a Star, a BMW, a Porsche or whatever. They say, okay, we try to help, but in reality, it was very big business for work from home, for the notebook market, like the CPUs and, all of this. So that's, I think, when regions have realized, we don't have access if this is really needed.
So it's because of the shortage, and you guys are noticing it. It's not because of the geopolitics reasons.
Well, I think
because it's relatively unstable these days, to say the least.
Right, but geopolitics are a big factor now, right? I think this is another layer of complexity. I think if you look at semiconductor supply chain, we are talking up to 700 process steps to make a final product. And I think Taiwan is probably really the only place in the world where you cover almost everything of it, I would say. I mean, even in Korea, they have a lot of memory, of course. But if you look into other segments, it's not so wide, for example, than in Taiwan. So I think that's definitely something what is very unique. And even if this money is now given to these companies to basically drag factories, at the moment we are mainly talking about front-end fabs. So this means wafer fabs. You need to have packaging, testing, design, all of this. So we need to, I think, when you're from the industry, you understand the front-end fab alone is not building up the supply chain. There's much, much more coming. And I think the biggest shortage issue I see in the future is talent.
Talent.
This is the biggest challenge for everybody. Get the right people to serve these machines.
But circling back to my question, will this U.S. bill, $50 billion injection subsidized, and also you say
The EU is proposing the same
EU
bill.
proposing, yeah. Will that actually help?
Well, it will help them because let's say the semiconductor market is at the moment at $600 billion US. There are predictions that by the end of this decade, it will be around about 1 trillion. Okay, 1 trillion. So they think that they can make this jump probably until 2030, 2032. So this means there is a high demand. So we are not basically thinking about, oh, it's a fixed market, and now this is in Taiwan, and if in the USA they're building this up, they take it away. No, you need to look at the strengths, what type of products you want to focus in which area, right? Like, let's say European Union, they're interested in automotive, right? They want the automotive part. That's not really cutting-edge technology, right, to do so. In the USA, maybe they want to look, I think TSMC committed maybe 5 nanometer, right? Maybe they do it.
Yeah, they're going to 5 nanometer, yeah.
Yes, so they will bring this there. So I think the market is getting bigger, and I think what happens is the supply chain is more balanced, right? I personally believe that still Taiwan will be the majority because the government has, in the 70s, I think, started to build up this very, very focused and very, very strong. So you can throw as much money as you want. You have seen this in China, how many money has been invested in the semiconductor industry, and they have not done the progress as basically they wanted to achieve.
No,
right?
not
They
at
have
all.
not.
Yeah.
So that's what I mean. This is a figure, it's a number, but to build up this ecosystem, it's not only about money. Definitely not.
So for future trends, do you see this as like something that where it's a start of specialization in different regions
there's
of the
different
world?
focus.
Like say the U.S. with this, as Catherine mentioned, the huge investment, $500 billion US, will actually be the start of specialization of a certain type of chip in the U.S., where Taiwan continues to be the powerhouse, continuing to provide the world with all these different types of, given its ecosystem.
I think from a customer perspective, it's also like a type of a risk management, right? What they are basically doing. And if you look at TSMC also benefiting from the CHIPS Act. So they also go to the US, they build a factory there. Maybe they build a factory in Europe. I don't know.
They are going to build a factory in Japan.
Yeah,
But it
exactly.
does come with restrictions, as say they won't be able to invest in China
Yes.
in the future with the CHIPS Act. So does this lead it to choose sides, like say with more like-minded countries in the region? Would you see that?
Let's put it
as a
this way.
possibility?
TSMC has a lot of leverage, I would say. So it's not so easy to tell them basically what to do. I'm not sure if you want to chime in there.
Yeah,
but
President,
I,
because every time when we do the show, everyone, whether it's investors or business person, want to ask how long will TSMC last? The legend,
How long?
right?
Yeah.
Right, the
Until
leverage,
until
like
the death
Marco.
of silicon. As long as silicon is a dominant material, I don't think that the leading position of TSMC will be affected, because even though there will be the end of the Moore's law, but TSMC can build a 3-dimensional chipset. All right, so they find another ways to long last the Moore's law. Okay, and also as Marco has said, you need to build an ecosystem. The ecosystem
is the hardest
including
part, right?
your educational system. In the US, even the professors, they don't know how to teach semiconductor processing because there are very, very little demand in the US for semiconductor processing. Okay, so all the professors in Taiwan, we know how to do it. And actually, most of the professors in Taiwan, as long as they are in the electrical engineering department, they work for TSMC for small project here, small project there. And therefore, we do have the whole ecosystem. So the US, you really think about $50 billion, a big number? It's not. In China, they spend $100 billion and they got nothing.
So there must be other important factors.
Money cannot solve all the
Everything.
problems. So the US need to build a good ecosystem. The problem is, I know how I've been in the US for 16 years. I know the American don't like math, don't like engineering. So Americans, they do not produce a whole bunch of engineers, and therefore it's very hard to recruit. good engineers to semiconductor industry. The first class US engineers will go to Apple, Google, Microsoft.
Software companies.
Software companies, okay? Because, it's hard work in the semiconductor manufacturing plants. You have to wear a very heavy coat.
And always
you have
on
to mask
call.
off, and you work maybe 12 hours
You
shift.
cannot use your cell phone.
You cannot use the cell phone. Is working condition is okay, but it's hard work. Okay, so first class engineers will not go into there. So if TSMC goes to the US,
What they're saying,
will
they cannot
attract
do hard work?
maybe second, third class engineers. They have the best talent from Taiwan. That's the big difference. That's why when they go to Japan, they ask Sony to join the investment. So they use the name of Sony to attract first class Japanese engineers.
Marco, do you agree in terms of the hardship?
No, I think he's right in the extent, for example, if you look at Arizona, where TSMC is going, they're already struggling, right? You also have
To find the right
find the
person
right
to work
people.
there, yeah.
And then also you need to see that, I think in the US you have also strong unions, right? Basically, where also the companies have to basically to comply with, depending in which area you are. So I agree what you mentioned before is like in Taiwan is really like if an engineer gets a call at night and there's an issue, they just go. They just go and try to fix it, right? Or if there's an issue, they work so long and so hard until it is basically done. So I think that's definitely something what I see, the work ethics and the work morale, like in the semiconductor industry, that people really, they see this as their pride, right, what they are doing. And that's probably, I'm not sure to transfer this into an economic system like in the US, where you have not really built this up, right? And I think there's a lot of talent fight right now between Intel, TSMC, Samsung, Micron. Everybody tries to get these talents which are existing, because like you mentioned, new talents is not coming so many. And even if they start right now, it takes 4, 5, 6 years. That this generation would come out and would be able to take these high quality jobs.
I see.
Right? Because wages is not really a challenge that we need to, I say we here in Taiwan don't need to be worried about some lower cost countries, right? Because what we are doing here is like high tech processes, right? Which is only in Korea you do this here, and in the US. So there's not any other country who does 5 nanometer or 3 nanometer. So we learn this here, and when we learn this here, of course, you can also build up a broader industry where the others don't have this. The others don't have a TSMC in their home. So that's definitely, I think this was a very, very good decision from the government in the 70s to look into this, and that's a competitive advantage. And I would chime in, what you mentioned is like that as long as there's silicon, I think we don't need to worry about TSMC.
But
I think one great thing that I think Marco mentioned was Korea, and I think you both mentioned the work ethic in Asia.
Work ethic, yeah.
Especially in Taiwan. But some argue that it's the same, say, in Korea or in China and in Japan, of course.
Well,
and they say Samsung's a very close front runner.
Yes.
Do you see that coming close in any time to TSMC, or say, would that come in par or either surpass Taiwan's competitive advantage, as you mentioned?
Well, I think Samsung has also the challenge that they are also in some regards the competitor to some of their foundry customers, right? You have seen this with Apple and so on. That's why basically Apple also moved to TSMC. So it's not a pure foundry model. Even Intel is not a pure foundry model. You also need to see the culture of Intel, right? The way how Intel has gotten big and the way how they approach the market. And now they're opening up as a customer service-oriented company. This will be a very interesting transformation to see how they handle this. TSMC is pure foundry. That's what they do. You have a design, you want to produce, that's what they do. You want to do this in 3 nanometer, 5 nanometer, or in 28?
We get it for you.
Yes, they get it for you. There's no competition or anything like this. So I think that's really a huge difference, right? UMC, I think it's the same. UMC also pure play foundry, right? So I think that Samsung will be able, and you have seen this in the media, that they are basically taking on some of the accounts, which also have been at TSMC. But frankly speaking, I think it's also healthy for a customer. You need to balance a little bit. It's not good for TSMC if they really make everything and everything goes there. So you need to chuckle a little bit. And I think this is the resilience of the global semiconductor supply chain. This new factory helps to spread a little bit the risk and the opportunity. Because as a buyer, you want to also have an opportunity to negotiate, right? If I only can go to one, it's very difficult, right? To basically get the best deal. So you need to have some healthy competition in order to do this. I want to say healthy, right? So healthy means really that it is driven by business decision, by business money, and not by subsidies. So that's another point, right? So the companies have to run by themselves, generate the profit, and then basically be able to give like good costs to their customer.
Right, so you think there are two different business models. One would be a complete foundry where the other is more specialized in some sort of, and even going forward, you don't see that change.
Now suppose Samsung wakes up, I say, I split off my foundry business.
They definitely will be. I mean, even today they are expanding, right? It's not that they are losing. They win new customers, right? So they are building up. But can they go to the level than TSMC with 55% market share? I'm not sure if I will see this as long as I'm working.
I see. Still have a long time.
I agree with you.
President,
because it's totally different businesses. Samsung used to produce DRAM. It's a commodity. It's a standard product. You have no customers to serve. But for foundry, you have faced hundreds of customers. Each one has a different demand. You need to have different processes for each customer. And therefore, you have to be flexible. You have to be accommodative. You have to do this, you have to do that. So it's totally different mindset to run the business. So think about Apple and think about the Qualcomm. Both of them went to Samsung. They all came back to TSMC. They failed.
Professor, we talked about the nature of the business and the difference of the business. But to a broader level, a global shortage of semiconductors started in 2020. And as MIC, a Taiwan government-sponsored think tank, think it will take up to 2023. Do you agree? And what's the solution to the shortage? Because the problem is imminent right now.
I don't think it's going to be an imminent problem. Why? Because we look at the year 2000, maybe before you were born.
Some, what, 22
year 2000, do you remember
Okay.
Y2K crisis? You don't remember?
Too young.
You guys are too young. You remember that, right?
Y2K
For that year,
crisis.
because all the computers can only run, I don't know, it's a 1999 with the calendar with up to 1999. So when the year 2000 comes, and then you have to change the computer. So in the year 2000, you have to change a lot of computers. And therefore, in year 2000, the demand for PC skyrocketed, and the semiconductor industry rate increased by 35%. But what happened to next year? All gone. They got a 2 years recession in the semiconductor industry. So
It's a roller coaster.
in the long run, I did some calculations. In the long run, the growth rate for semiconductor industry is only 6%. And therefore, from 2021 to 2020, because of the pandemic, and therefore the demand for the semiconductor has increased 26%. And then what's happening in 2022 and 2023? It will come down. Because now we have very durable PCs. You don't want to replace your PC or cell phone every 2 years. And therefore, the problem will ease in the next 2 years.
But from what I gather, the gap is 20%. The demand is increasing because of the pandemic.
There's old days.
It's
Sorry,
gonna
gone.
end.
It's gone.
It's gone.
Because everyone's going back to work.
Because everybody goes to work, and you bought the PC for kids in the last 2 years. You don't want to change that.
So you're saying it's cyclical.
It's
Every 2 years it
cyclical
will come
industry.
back.
In the long run, I did the calculation from 1990 to 2018. The normal growth rate is 6% for the semiconductor.
But are you
That's
only
it.
talking about the chips for PC, but in a broader
In
sense?
the broader sense, whatever.
What
you
for
have
cars, for
you have car,
everyday
you got PC, you
electronic?
got this, you got that, right? But think about 1990 to 2018, for 28 years, the growth rate for the semiconductor, 6%, no matter what. You have new devices, remember, we got the cell phone, okay? Each year we produce 1.4 billion cell phones. It uses a lot of chips. Even with that growth, you still on average 6%.
Okay.
Because they have done so well
So
to lower the cost and compact the chip. You don't need that many chips anymore, right? You can compare 3 chips into 1, and therefore you don't need that many semiconductors for the same device. And therefore, in the long run, only 6% growth rate. So this year, in the last 2 years, the growth rate, 26%, but next year, come down. The year following will come down. Okay. That's my prediction. I don't know, what about yours?
Well, I think if you look at the semiconductor full market, the CPUs are around about 1/3 of the semiconductor market. The memory is 1/3. So this means these two combined already is 2/3 of the chip market, because you mentioned it's not only PC notebook, right? So there is also others, but you have
all kinds of others.
Right, but already these two, basically they are 2/3, so then you have basically 1/3 left over for the other chips. So they have a big influence on the growth rate. But I would say because of the electrification, like in the cars, the chips are multiple chips now, which are basically used, even in the combustion engine cars, right? You have a lot of systems like autonomous driving, you have basically sensors everywhere. That's why we have so many issues, in the supply chain for the manufacturers, because they need much more semiconductor. You have higher density in the mobile phone because you have high density videos you are recording. You want to get more in the same form factor, right? So even maybe you are not selling more mobile phones, but you are putting more memory in it. So this is also increasing. So I personally believe that the situation from 1999 to 2000 in regards for demand is a little bit different, because in 1999, 2000, the semiconductor market was very much driven by PC and notebook market, right? This was really the main share. Today, if you look, for example, on memory, the majority is data center, right? So this is really like cloud, hyperscalers. So this is where the majority of the business basically goes. And so I think these 6%, I also agree. This I think is something what is realistic. And when you have like 27%, the party cannot go on like this, right? So there will be some correction. But the correction is when you say in general the shortage is next year over. I can tell you already this year some shortages are over. There's already pricing coming down and some improvement. But there are still pockets, for example, MCUs, FPGA, where still the supply is pretty tight. So you have to look at it from the industry perspective. For me, I look very differentiated on it, right? Because if somebody say, oh, the shortage is over, and I say, no, because the MCUs like Renesas, ST Micro, I don't see too much improvement there. But on the memory, oh yeah, the price goes down like 10%, 15%. But in memory, I'm used to this because it's cyclical. It's normal. That's the flow, right?
That's your life.
That's it, yeah.
In this sense, can you make a projection? What's it's going to look like 2023, basically, next year? I mean, the shortage, the supply, the different focus, what EU has and America has, and also
I think
Taiwan.
what I read, I think this week, there was the TSMC symposium, and I think they announced 2024, they go online with 3 fabs, Japan, US, Kaohsiung. So I think I'm more looking into 2024.
Sure, of course.
Because I think that's when some capacity will come there, because we talked during the pandemic about it, right? Then the money is spent, the factories are building up. I think at the moment the can is kicked down the street. This means like you have in China the issue with the smartphone, the PC market, because of the lockdown. So the anticipated growth rate of 5% this year in the smartphone market globally is not happening. Instead, it's less than last year. And so this demand, what basically has been reduced, has to come back and will come back. And the moment when this is coming back, this will help to take out of this dip, right? So, and I would assume we would see this probably second half next year, maybe second quarter, that there would be a change in this. But when we look at semiconductor, we need to look really more into the categories. Let's say CPUs, memory, and other type of commodities. There is not anymore at the moment the general chip shortage. There is still shortage, but you need to understand the pockets where there is the shortage.
Speaking of pockets, which areas do you feel that Taiwan and say, its like-minded allies are more going to specialize in? Say, China's a different market and it has its own specialty, because in the future with more defragmentation and with the US and China conflict, how would you see which areas of the Taiwan segment or sectors that you mentioned would be of focus?
Well, I think that it's clearly for me the high end and cutting edge, right? I mean, if you look like ASML from the Netherlands investing heavily in Taiwan, right? I mean, TSMC is their largest customer. I think most of the EUV machines are basically going to TSMC. So it's not only the TSMC is committed, also their sub-suppliers is committed, right? So they also come here to Taiwan in order to help. Or for example, automation companies like Beckhoff, like from Germany or from Europe, they're helping also like the processes, the Industry 4.0, Siemens, they all help basically to optimize this, that you are competitive there. And so that's where I believe this market segment, high-end cutting-edge technology, and then to a certain degree, I would say also some legacy technology. I mean, we talked before about memory companies like Winbond, like Nanya, like PowerChip. They are also serving a certain market segment, right? Even if it's smaller comparing to the Koreans. But they are good there because nobody can just start, I make a memory company and spend $10-12 billion and having no patents and nothing. It's not possible. So there, I think Taiwan has a very good setup to be successful also in the future.
Go ahead.
Yeah, also to be successful in the future.
And some areas that Alex mentioned earlier, actually, that there might be opportunities for new players that are, say, like-minded countries, say from the UK or either Australia, to have a role in semiconductors. Do you see Taiwan playing a role with these new players? As you mentioned, there'll be new suppliers and all that, given how large this market is.
Well, I think Taiwan probably will go into a system to build something up where there is for them like a certain specific market. Let's say in Europe it's automotive industry, right? So I would say in the US it's, for example, all the data center people with the specialized CPUs. I mean, Google has their own CPU, Amazon has their own CPU. All these guys are making their own silicon. They have their own team, and then they go, for example, to a TSMC to do this. So you need to see the scale of the market where they would go, right? And so I think Taiwan is also looking probably to cooperate with India, which is also like a huge addressable market for them. So I think this, I believe, would make sense to look into opportunities, to look into these markets. For the others, I'm not so sure, because there has to be some specific need to do this. You are not building a $12 billion fab just to serve an ally. So you need to have a market there, right? So you need to have basically a purpose there. But I could imagine maybe on an academic level you have cooperation, right? I think this is maybe something on design. This is I think this definitely could be, because I think also Taiwan would be good if they have the opportunity to get talents into the country, right? So I think Taiwan a few years ago you introduced the gold card. Right, so where you basically get talents from outside come to Taiwan who serve a specific need for the industry here. And of course, semiconductor is always welcome here to help the companies here to build up. Because even probably with the 13,000, Mr. President, you mentioned, is not enough.
It's not enough.
You need more. So the government, maybe one question what they can do is to help to make it more easy to get these talents into the country, right? To help the industry here to grow.
Speaking of innovation, the key to developing technology is talent. Earlier, I spoke with Conrad Young, former research director at TSMC, currently based in Silicon Valley, on why Taiwanese talent is so critical to its semiconductor success and what it takes to maintain that competitive advantage. Let's take a look.
Conrad, having led the research team at TSMC, can you talk a bit about the advantages and disadvantages you see with many years of you overseeing Taiwanese talent in the semiconductor industry?
I guess the reason is it has a basic STEM education training. All the training are very solid relatively to the US-born people. So that's why immigrant has an advantage. And because they, generally speaking, are willing to study the detail, the technologies area, and they are more commit and more, I call it 3D, is disciplined, dedicated, and devoted. And they are more obedient and also humble. This is very important for a technologist with customer-centric mindset. Okay, there is a slight disadvantage. In general, Taiwanese talent are less creative. However, the less creative probably is less important and also less needed for the technology and the manufacturing area. It's probably more on the innovative industry like software application, big market, that kind of things. So Taiwanese talent is really, I would say, is ideal design for semiconductor technology.
You talked about innovation and that Taiwan's talent industry is very designed or fits well with the semiconductor industry. Can you share a bit on what are the secrets to Taiwan's success in its decades-long journey to becoming now the world's foundry?
Well, it all started at the late 80s. TSMC started a company in 1987. I think the key issue is during that time, there is essentially very little competition from all over the world. Nobody except Taiwan and one small Singapore company working on so-called pure foundry. Most of US, Japanese, even Korean company focus on the product company. We actually call it IDM. So in the foundry business, there is very little competition for TSMC. And TSMC started the first 10 years focus on manufacturing with customers' technology. Basically, our customer transfer the technology to TSMC to fabricate, to manufacture their product with their technology. So TSMC only focus on manufacturing. After the 1997, so the second 10 years, from 97 maybe to 2007, TSMC start to develop their own technology. For example, I think we start to catch up in 0.18. I was in charge of 0.18, 0.13, and 65 nanometer. That was the golden 10 years for TSMC. Start with no technology or other people's technology to our own technology. Okay, so those 10 years we have the TSMC had a moderate growth. And for the past 10 plus years, after the economical downhill, the supply issue, TSMC decided to invest more capacity. So for the past 10 years, 10 plus years, TSMC using the capacity expansion and add a lot of resource, so to kind of widen the gap between TSMC and then other people who is going to enter the foundry. For example, Samsung, which is probably started around 2010 to 2012. That's at least 23 years later than TSMC. So at that time, TSMC has become it's a very big company. So, and the leadership is established. So it's very hard for the second foundry company to catch up. That's the reason.
You mentioned how late companies such as Samsung came in and they were later than TSMC, but we've also seen a lot of poaching from such companies. Mm-hmm. And oftentimes they give more competitive incentives, higher pay. How does TSMC or other Taiwanese foundries deal with that in terms of, having a talent drain?
Yeah. I think higher pay is an attraction, but it's not the only attraction because of for Taiwanese, they need to go overseas, living in the other country. So they also have their career enhancement. And typically, when you are in the other country, they feel there's a glass ceiling for their the promotion and then the career ladder to go up. And also, living in other country is a little bit more difficult culture-wise to fit in. So it's a lot more complicated than just money itself. Yes, maybe there's an initial attraction, including the career, but Korea only has a wire. Okay, the Samsung is trying to attract a lot of people, but many people from Samsung, after Samsung becomes successful in to establish foundry, most of the people actually left. China has a similar problem, and for U.S., one of the problems for U.S. Is the immigration quota issue. So it may not be as easy for those Taiwanese people come to U.S. As much. Okay, that's the so-called pool for other country to pull the Taiwanese people. Actually, there's one particular issue which Taiwan company could do to help to improve I call it push. There are certain push for the Taiwanese company push the talent outside. I think one of the problem is the working environment and the culture. Sometimes how Taiwanese company treat their own talent, okay, especially the recent maybe 5 to 10 years, the environment is less friendly to the Taiwanese talent. So there is a certain push, which is actually by the Taiwanese company. If a Taiwanese company can minimize the push, that can help. And also recently, probably because of Pelosi event, there is a geopolitical threat with maybe China's threat. So people start to feel the safety issue. So that's also a potential push. So I think for Taiwan, you just need to minimize the push. And for U.S., the pull, the issue is the immigration policy. But recently, I think the senator is trying to do something. Okay, so there's a push and pull issue for the Taiwanese talent moving outside. Okay, for at least for Taiwanese chip maker, they need to minimize the push.
So you talked about minimizing the push. How would they do that specifically? Do you have any suggestions or ideas or ways that they're going to do about, keeping talent from flowing out?
I think they need to improve the working environment. Okay, make the environment is more friendly, especially to a younger generation. We call Generation Z generation. Okay, the people who want to have a better life, has a slightly better life and work-life balance, and which is very different from the early X generation or even baby boomer. So the environment need to be designed better for them. And also at this time, because there are so many people, they might need to think about more efficiently use their talent. So give the more either freedom or more career advancement opportunity for them.
President, they said that economy and politics, they are not separable. And what we talked about so much for the past few weeks, the potential threats that there might be war happening, and we're assessing its possibilities. But what does it mean for TSMC in Taiwan if and when it does happen? Does that mean that the China will use this and tilt it to advantage and then completely, have the more power to battle with U.S.?
There was a saying that if China takes over Taiwan, and China will control TSMC, and therefore they will cut off the supply of semiconductor chips
to the
US. And therefore they will have more bargaining power over the US. But the theory is wrong, plain wrong. Why? Because TSMC needs machinery, equipment from ASML, from other American companies, okay? And producing the semiconductor chips, it requires a lot of special chemicals that we imported from Japan. Without the machinery, without the chemicals, you cannot produce semiconductor chips. And therefore, by taking over Taiwan, controlling TSMC, and you just make TSMC as obsolete. There's no reason for them to do so, just simply because they want to control TSMC. So if there's a war, there must be something else happening, not for TSMC.
But others will argue that in the opposite point of view, that Taiwan should use this power advantage to say to the world that we have this advantage right now. So come protect us. Japan, Japan, US should protect us more if and when it happened. I mean, the war.
But how could they do it? Think about this, okay, just like the Gorbachev is dead.
Through diplomat measures.
Well, there's a theory called trembling hand equilibrium. What does that mean? Before you were born, there was a Cold War between US and Russia, right? And Russia, will announce that I'm going to invade West Berlin, okay? And the US will tell Russia, if you invade West Berlin, I'm going to fire my nuclear missile, destroy Moscow. And Russia will say, you destroy my Moscow, I'm going to destroy your Washington, D.C., okay? And the threat is not credible because in the morning, and then in the 3 o'clock in the morning, and President Reagan at that time wake up and say, hey, wait a minute, Russia has already invaded Berlin. What should we do? Should we fire a missile to destroy Moscow? Of course not. Why? Because the Berlin has already been occupied. If you fire a missile to destroy Moscow, then you cannot take back Berlin. And therefore, this is not a credible threat by telling the Russia, I'm going to destroy your Moscow. There's only one small chance that Ronald Reagan was very, very old. He has a trembling hand. And somehow, for 1 million chance, he could touch the red button and fire the missile. And then the threat is credible. What does that mean in China? Suppose now China takes over Taiwan in 1 day. And then
it could happen.
What would the US and Japan do?
No trembling hands these days.
Yeah, there's no trembling hand right
Biden.
now. Biden is as old as Reagan. There must be 1 out of 1 million chance that Biden may touch the red button.
So what are you saying? Politically, we shouldn't weaponize TSMC. It's not going to happen.
It's not a weapon.
The government's role is to protect the country, national security, and semiconductors is Taiwan's key industry. And the government puts a great focus on maintaining its competitiveness. Apart from the talent aspect, what do you think the government can do to continue having Taiwan's industry's competitiveness?
Well,
great question.
Don't tell me about except for the talent. Talent is the biggest problem because we have a low birth rate right now in Taiwan, very low in the world, and therefore we will see the number of engineers will come down in the next few years, and therefore gradually, if we do not import engineers from other countries, and then we will have serious trouble. So the best thing for the government to do is to lift all the restrictions of foreign engineers to work in Taiwan, to lift restrictions on foreign students who want to study engineers in Taiwan. That would be the best thing for the government to do.
Thank you so much for your insight. And that's a wrap for today's episode. We talked about the key factors for Taiwan's advantage because the compact ecosystem, the quality of the talent, and also the general economy system. And also we talked about the history, we talked about looking forward. Maybe we shouldn't be that nervous about the Samsung or China's competitive advantage.
Or even an invasion.
Yeah, invasion, of course. And thank you so much for watching this show. I'm Catherine Liu.
I'm Rath Wang.
I'll see you next time. Thank you.